Here are the answers for the sheet which you have as revision question 3. Revision questions 3, I should say. So question 1, you have to explain about a pure inductor and a pure capacitor. So apologies if this gets scruffy, but I'm going to do it fairly quickly. And I've got a phone in my way. So there is the voltage. What does an inductor do? Well, it's going to delay the current by 90 degrees. So the current is going to reach its maximum 90 degrees later, which is about here. So it's going to do something like this. Hope that makes sense. So, and you wisely add in some words that in an inductor, current lags voltage. I haven't got the paper in front of me. I think that was 4 marks. If it was, you'll probably get 2 for this one and 2 for the next one. So that was a pure inductor, a pure capacitor. Let's try and do something similar. So something like so, that'll do. There's the voltage. And in a capacitor, current leads voltage, so it's going to reach its maximum 90 degrees earlier. And it's going to do something like this. That'll do. So there's the current. So in a capacitor, current leads voltage. Again, 2 marks. I've maybe been generous there, but I've just invented the marks. You have no idea what EAL are going to give you for marks. So that was question 1. Question 2, you were given some very specific figures, and it says draw to scale. To scale, use one of these. Use a ruler. And basically you're drawing the impedance triangle. So I'm going to sketch it very quickly, but you do it with a ruler. So 50 for R, so perhaps 5 centimeters. So R is 50 ohms. And the reactance is, that's X, and that was 70 ohms. So do all this with a ruler, and you're going to join that up, and you're literally going to measure it. Oops, not in inches. You're going to measure it, and the measurement you get is the impedance. And if you've done it reasonably well, the answer we're looking for is 86 ohms. Because there's a little bit of a chance of an error when you use your ruler, I will have a tolerance. They'll tell me how much I can mark it by. It might be that an answer between 83 and perhaps 89. They might give me something like that. And as long as you do that, you'll get the marks. Can't remember how much that was worth. Probably 2 marks. Not sure. Okay, so hope that bit's clear. The next question was in many parts. Tell me the part that you're answering. Part A. So question 3, part A. First bit, reactance. XL is 2 pi FL. At this stage you should know the routine. Without this formula you're going to drop a mark. And make sure you get XL if it's a coil of wire, XC if it's a capacitor. Put the numbers in. 2 pi times 50 hertz times the value of the inductor. And that comes to 62.8 ohms. Typically for EAL this will be worth maybe 2, maybe 3. I'll be generous today, let's call it 3, and I would give you 1, 1, 1. If they gave it 2 marks, you'd get a mark for the formula and a mark for the answer with the unit. If you miss the unit off, you're going to drop a mark. Okay, so that's 3A. Let's have a look at 3b, so we're still on question 3, part B. Impedance, Z equals a formula you've met many times. Put the numbers in that you have. R was 35 and XL was 62.8. Don't forget to square them, square root the lot, and that comes to 71.9 ohms. Not sure how EAL might mark it. Could be 1 and 2, could be 1, 2, 3. So this one I'm going to say it's worth 2, and you get 1 mark there and 1 mark there. So part C, find the circuit current. Ohm's law, I equals V over R, but it's an AC circuit, so I equals V over R. It's not R, it's Z. So the supply voltage was 110. Z, you've just found 71.9, giving you a current of 1.53 amps. Again, possibly 1 mark, or 1, 2, 3. I'm going to go on the tight side and say it's just 2, 1 for this and 1 for this. Part D, same question. Find the power factor. I could write power factor, or I could write cos phi. They mean the same thing. In this circuit, you've got the information, R over Z. Cos phi is R over Z, and the resistance was 35. The impedance you just got, 71.9, and that comes to 0.487. No units. Final part, part E. It's an E, not a C. Part E, find the phase angle. The cosine of the angle is this. So the angle is cos to the minus 1 of 0.487, so that number. And if you put that in your calculator, I'm hoping you're going to come up with 60.9 degrees. If you wrote 61, I would give you the mark. Okay, so I'm hoping that makes sense. On to question 4. Let's check I'm still lined up. Okay, so on to question 4. The simple thing here, it's asking you about power and the power triangle. So it's a very simple question. A sketch will do. There's your phase angle. KW, this is true power. Apparent power is on the hypotenuse, kVA, so that's apparent. And reactive, up the side of the triangles, is always caused by a coil of wire or a capacitor. Their value changes with frequency, which makes them reactive. So this is reactive power caused by a coil of wire, and that is kVAR. Okay, not sure how many marks were allocated for all of that, but it was probably a 2-pointer. So probably 2 marks if you correctly labelled in the right places that triangle. Other questions could easily ask you to give a short explanation of each one of these for very few more marks. Okay, the last question on this paper, question 5. You were told that a circuit had 2.5 kVA and 2 kilowatts. That's looking at the power triangle. So 2.5 kVA, you need to know where to go, and anything to do with resistance is kW, kilowatts, and that was 2 kilowatts. So good formula to have. Power factor equals kW. So apologies, gents, my brain's running ahead. kW over kVA. That's the formula you want. And if you put the numbers in, it's 2 over 2.5, and that comes to 0.8. Just a quick check on your answer. The number is between 0 and 1 for power factor. If you get 1 point something, you've gone wrong. Okay, so I hope that helps.